and a very good afternoon to you. Thank you for joining us for today Energy Innovation 2021 Startup Showcase session. My name is Ryan Jin, and I'm leading the Smart Cities and Future Mobility effort at Ecolabs Center of Innovation for Energy, or Ecolabs for short. I'll be hosting this session. Earlier this afternoon, we have seen many energy innovation projects undertaken by companies with support from EMA. Just prior to this segment, we see many research projects happening in Singapore at NTU, A-Stars, and the Singapore Energy Center. And now, at this segment of Startup Showcase, we bring together 8 innovative startups across the energy domain in areas of energy efficiency, natural gas, next generation grid, solar and energy storage system, where many of them are in the process of bringing the research technology to commercialization. Before we proceed, I'd like to start this session by introducing what we do at Ecolabs and how do we value add to the Singapore energy innovation ecosystem. Ecolabs, jointly established by Nanyang Technological University, Enterprise Singapore, and the Sustainable Energy Association Singapore, aims to build and accelerate deep tech energy innovation capabilities in Singapore to support the nation's future energy transition. These joint initiatives aims to help Singapore-based energy startup and SME to successfully commercialize and scale their innovation efforts by providing 3 key service offerings: translations, accelerations of technology to solutions, and commercializing these ideas, projects, or solutions to market. Under translation, we support co-innovation projects, pilot, test bed, and consortium projects. On the other hand, the acceleration side, we provide services in investors service, startup services, and founders program. Given our core strength in the translator and in accelerator space, we work with startups with technology readiness level of 7 and above, i.e. tech validation done at lab and ready for a system demonstration. What also makes us unique is our access to in-house experts across the energy topic. NTU has sustainably ranked high in global ranking in material science, engineering, energy and fuel, and nanotechnology. Our partners can benefit from our pools of highly accredited expertise accessible to us. I would also like to point out that Ecolab's parent institutions, the Energy Research Institute at NTU, has strong capabilities and track records in the energy innovations with our global partners and industrial players. On the commercialization end, the Ecolabs team also help to connect startups with investment, funding, and business opportunities to provide a business-driven outcomes. So for today's sessions, we have 8 promising startups presenting to you on their companies and the latest innovation in the energy domain, featuring solutions such as vanadium redox flow battery from VFlow Tech, a smart IoT battery for electric mobility and consumer electronics from Anzen, an intelligent energy management solution with machine learning algorithm from Freesync technologies, and decentralized energy network platform Python by Pylon City, and AI-driven advanced drone imaging technology and digital solution for PV asset management by QE Labs, a PV regeneration and recycling technology company by Itavut, and high-performance and cost-efficient hydrogen electrolyzer and stack solution from SunGreen H2, a new nanomolecular filter that allows hydrogen recovery by DBgas. Each startup will have 5 minutes to give their best pitch to you. Presenters are reminded to keep to your allocated time, and at the end of the 5 minutes, we will politely ask the presenter to conclude. Due to the time constraint, we will conduct the Q&A at the end of all presentations. Attendees may post your question in the chat box at any time to all panelists. When posting your question, kindly include which startup the question is for so that the particular startup may reply accordingly. As we aim to bring together partnership and collaboration through this startup showcase, you may indicate if you'd like to be connected with the startup at the end of the respective presentation. We will facilitate the connection post-event. Now, without further ado, I would like to bring the first startup, VFlow Tech, presented by Dr. Abhishek Kumar, co-founder and CEO. Dr. Abhishek, please.
Thank you, Ryan. Good afternoon, everyone. I'm Abhishek from VFlow Tech, and at VFlow Tech, we are building innovative, reliable, long-duration energy storage solution to power the renewables and get the full benefit of renewables. We are going in a decade where decarbonization and energy transition are the key, and two key enablers we see is renewables and EVs. Now, the main challenge is that both are intermittent. You have intermittent demand rising, and you have intermittent energy that is rising. And the world need bridge. The bridge rightly is a battery. And at current moment, the world needs a lot of battery technologies. And each battery technology has certain application. And if you are able to find right application with right technology, there is economics. And one such technology is vanadium rust flow technology. The technology is phenomenal in terms of lifespan. It is able to give you a constant performance over lifetime, 100% recyclable, 25 years of lifetime, and it's super safe in terms of depth of discharge, in terms of overheating capacity. Now, each technology had certain demerits, and rightly so. Flow batteries were plagued with number of issues. And the key issues with flow batteries were traditionally they were suffering from low energy density, low efficiency, high cost of vanadium, and instability. At VFlow Tech, we have been researching on this technology for last 7 years, and we have been finding issues on this. We have understood what are the reasons for low efficiency. With our advanced stack design, we have been able to improve the round efficiency by 10%. We have also reduced the parasitic losses to a record low, and we have developed an organic additive that allows us to operate our battery in hot and humid conditions up to 60-degree ambient. And this also allows us to improve our energy density. Now, gone were the days when batteries were used for certain applications. We understand that battery in future is going to play multiple roles: peak shifting renewables, frequency regulations, powering the grids, and many more applications. And for that, the world needed a smart energy management system. So VFlow Tech, we have developed an advanced battery management systems. Our battery has roughly 12 sensors, which keeps a track of the voltage, the sensors, the flow, leakage. And with the BMS and smart actuator technology, we are able to hold our pumps and stop the pumps. That allows us to improve our efficiency further and improve the response time up to 20 milliseconds. So our battery can respond in less than 20 milliseconds. Plus, on top of BMS, we have an advanced energy management system that understands the need of consumer, how it's being behaved, what are the available in natural resources, and it becomes smarter each day it operates. And the technology outperform other technology in this space in terms of operational flexibility. So we are good to charge from anywhere between 4 hours to 12 hours. We have a longer asset life. So our life cycle has more than 10,000 cycle, which is roughly 25 years. Wider temperature range of 60 degrees Celsius, where our traditional technology works at 25 degrees Celsius. And it's safe and reliable with no explosion and exponential risk. We have not only we have developed our technology from lab scratch to a full-scale industrial cycle. We have put one of our system in Clean Tech 1, which is being powered almost for a year, and all the performance and efficiency that we have claimed can be validated. I was talking about our advanced EMS, which takes in the clouds. It's also called Cloud Internet of Energy. In the cloud, it can control how the energy has to be distributed from solar if the load increases, not stressing the grid, and battery come into a picture. We have worked with a leading oil and gas company looking to decarbonize an island. And there was question that can your battery form a grid and handle a high inductive load? We have put a battery on Jurong Island, formed a microgrid, saving 7,000 liters, powering 20-year-old inductive pumps for almost 3 months. We are now working to convert a few of the large tanks and explore the viability to go up to a gigawatt scale. We are working on a case study on one of our islands where they are consuming about huge amount of diesel consumption, using 2 tanks and create a 40 megawatt hour systems. We are now doing in a design stage feasibility, which will be scaled up soon. We have recently got a contact from a Korean company and a Korean government to mitigate renewables because the wind energy was wasted. We are converting existing gas station into a EV charge using their tanks to create a high efficiency flow battery EV charger. That contract is now in place with a Korean company. And this Korean company has many such pilot. We have been getting a lot of attention, and we have partnered with an Australian vanadium company to bring in to develop flow batteries for hydrogen cell in a Malaysia project. And we have been also working to decarbonize big mines in the region. We have, energy is the second most desired thing in the world after food. And we have formed a joint venture partnership with Syncfuel, an oil and gas company, to build microgrids in Africa with our own software platform. And this is in place. And while we are talking, we are building few microgrids in Africa. We are supported by, thankful to Temasek and Enterprise Singapore. And we have a team that is experienced in handling flow batteries and renewable energy. Thank you.
All right, thank you so much, Abhishek. So now we will put out a poll. If the audience are interested to get connected with Abhishek from VFlow Tech, please feel free to drop your comments. All right, we can see that there's a lot of votes coming. So we just give another five more seconds for this. Please key in your votes. All right, so right next we'll be inviting the next startup, Anzen, presented by Joshua Chua, co-founders. So Joshua.
Hi, I'll be sharing the screen. Good afternoon, peers. My name is Joshua, one of the co-founders from Anzen. Unfortunately, we cannot hear the video, so I'll be just talking about the summary. As mentioned from the video, the irony of green economy push will create a staggering 50 million tons of used lithium-ion battery. So we innovated an evergreen and universal battery pack that can charge both mobilities and electronics. This allows you and me to save the environment and money at the same time. The three main features are, first, 99% of the block can be recycled as components are connected by connectors instead of conventional soldering, reducing the time to separate the parts. Second, it will power variable voltages for different current mobility such as wheelchair, scooters, and bikes, allowing the company to work with suppliers and supporting existing end user easily. Last, safety is paramount with so many use cases. It also comes with a patented extinguisher capable to be nested beneath battery cells and protects the entire block independently. This will prevent all kinds of fire and explosion. The 700 mAh block removes daily charging at home and promotes renewable energy usage with IoT through gamification. These unique innovations have IPs on a business model patent in China and utility patent for the explosion prevention tech in the battery. We co-own with our China partners for China intellectual property management, so to build a win-win cooperation and independently own the international IPs. We can be market leader as our proprietary battery can power 5 different e-mobilities, while competitor has only one. It must be a specific vehicle. Cost of infrastructure is 31% cheaper, allowing 99% recyclability. And power against volumetric on our side is 53% better. It has 5 types of revenue stream, protected with a business model patent, allowing the platform to have barrier to entry and stay competitive constantly. Electric trends will grow a 22 billion electric mobility market. This is equal to 30 million new bikes bought to replace the old bikes. But we are targeting the 300 million current user that has a shorter sales cycle due to the aging battery at 10x the forecasted market size. After that, we will roll to the rest of Asia Pacific when opportunities open up. We will sell the hardware to end user through an online and offline store at a 40% margin. After achieving about 5,000 users, swapping services will be provided to the end user on a monthly subscription and will be expanded for rental for powering electronics on year 2 at no extra cost. The services revenue received will be distributed among 2 partners. Anzen will take 90% to maintain our services. Franchisee will collect 10% on top of the sales and the products and services. This creates a win-win proposal for a green economy supply-demand. Personally, I have 15 years in mobility industry and 5 years of launching new products to market. Our CTO has 10 years of battery and EV charging experience in China. Together with this team, we'll be able to bring our services to the marketplace successfully. So far, we have set up an assembly line and started batch production for certification. So about 230,000 of electric mobility signed with 4 franchisees and is in the process of getting 36 franchisees by the end of 2021 in China to sell to 10,000 users. The hardware standardization we are building can scale up a cooperative energy platform that can also benefit the user, society infrastructure, and end user like you and me. Once certified by 2021, the swapping service will be available through 40 offline stores. Anzen Evergreen Energy Block will recycle and repurpose up to each cell level to use from any mobility then energy storage. Year 2021, we will have 40 offline stores to reach out to 10,000 end users in the market. Next year, year 2022, we aim to reach out to 100,000 end users and eventually 1 home energy storage in each home. In the pursuit of greener economy, this will unlock the most eco-virtual power network with renewable energy, and it provides many tangible, usable ways in the market. Together, we can actively prevent a climate change tsunami, ensure energy independence and freedom, even during natural disaster. Thank you.
Thank you, Joshua. So this is Anzen, presented by Joshua. We will put out the poll. If the audience would like to be connected with Joshua, please vote in the poll as well. So for audience, if you have any questions to any of the startup, do feel free to post in your question in the chat box, indicating who your question is addressing to. All right. So we'll give this about 10-15 seconds before we move on to the next presentation. All right, so right next will be Freesync Technologies presented by Amir Runov, co-founders and CEO. Amir, please.
Hello. I think I'm unable to turn on the video. The host has to.
Hold on. Can you try again? All right.
Yeah. Okay. Okay, hello everyone. My name is Amir. I'm CEO and co-founder of Freesync. Based in Singapore, we started around 4 years ago, and we provide intelligent energy management solutions for enterprises. The reason why we started all of this, as you know, the whole energy infrastructure is going through drastic transformation, and this transformation is mainly driven by a few factors. Of course, drastically dropping price of renewables like solar or wind energy, digitalization of the whole ecosystem with internet access almost everywhere, with smart meters, with IoT devices, adoption of energy storage systems, like we heard in the past two presenters. Batteries and electric vehicles are taking over the market. And of course, implementation and adoption of AI and machine learning models for the automation purposes. So 4 of these pillars driving traditional grid towards what we know as smart grid or smart city solution. And at the heart of this transformation lays the data. So whichever company using their data efficiently can save up to 30% of their energy usage. And that's what we provide and enable at Freesync. So we ensure that we provide cutting edge technology, which is enhanced by AI and machine learning models that we develop in-house. We provide fully reliable infrastructure in terms of data aggregation, storing, processing, and then feeding it to the customer. We made it affordable so it can be used by small SMEs, but at the same time by the large MNCs. We can scale our solution from one site to hundreds of sites within the matter of few hours. We are fully cloud-based. We are based in Singapore, but we serve customers across 7 markets, and we can customize our solution depending on a customer needs. Quick overview of how our solution works and what do we do. We can provide our solution to the individual stakeholders, be it an IoT asset owner, or be it a solar power plant operator, or a smart building operator. We can ensure the real-time data aggregation, processing, and then not just monitoring, but taking real-time control actions on the assets. So we take real-time control action in order to optimize the site performance, to ensure monthly electricity bills and the good health and carbon reduction of the site. At the same time, we work with some of our partners on the large scale projects, which we treat as a virtual power plants, where we basically address multiple buildings, multiple distributed energy assets, and synchronize them between each other and provide the smart microgrid operation to the end user. And all of this data is processed. Some of them are processed at the edge, but some of them are sent to the cloud, and on cloud we run it through different type of machine learning optimization models and then feed it to the customer in order to understand what's going on within their sites. Our core product is our analytics platform and real-time control platform, which is compatible with all tier 1 hardware manufacturers. We work with Huawei, Schneider, ABB, SMA, you name it. But at the same time, some of the customers, they require end-to-end solutions, so they ask for the turnkey proposal. And we can provide hardware plus software combination. So we have our smart controller device, which is Freesync Omega, which can communicate to up to 50 devices on the site, take real-time control actions, and aggregate all real-time data, and can store data up to 6 months. At the same time, we recently launched our Freesync Gamma, which is a smart power plug solution. We can aggregate the data and then process it at the edge and provide real-time performance analytics to the end user. We started our focus with renewable asset management because that's where the prior knowledge of the founders coming from, but then we expanded to smart buildings. In fact, we received one of the EMA grants in early 2020, is a smart AI for smart buildings, and we commercialized our solution within Singapore. We work with telecommunication businesses where we help them to manage their distributed telco towers. We did our solution for EV and mobility. We did a pilot run with Nissan in Norway for that. And we have some microgrids in a region where we manage off-grid and hybrid systems. Quick overview of the unique part of our solution. We have our software basically helps customers to disaggregate their loads without installing any hardware on the site, additional hardware. So imagine all of us receiving our bills, electricity bills, but imagine if we can give you the overview of breakdown, what type of assets you are using in real time, at what capacity, without installing any additional hardware on your site. That will be perfect, right? And that's what we do basically. So we work with local partners, how to distribute to all households in Singapore this solution. But at the same time, we can provide the same solution to the commercial buildings where we help them to disaggregate their distributed assets like HVAC systems, servers, and heating elements within the building. We have quite a bit of customers on board, which is mainly by solar customers. We have around 600 megawatt of solar assets that we're managing, as I mentioned, across 7 countries. Quick snapshot of our solution. We dive up to the component level details, forecasting of the asset performance. We do facility management and predictive maintenances. We are a B2B company. We charge one-time integration cost, and it's an annual subscription depending on what type of services you are signing up and for how many assets. Fully Tech team founded by 2 tech engineers, myself and my co-founder. Yep. So that's a quick overview of Freesync. Thanks a lot.
Thank you, Amir, for the presentation on racing. So we'll put out a poll for audience who are interested to get connected with racing. To indicate in the poll right now. We will open this for about 10 to 15 seconds. For audience who have any questions to any of the startup, feel free to drop your question inside the chat box, and we will get the startup to respond to you or respond during the Q&A session at the end of today. All right. So another 5 to 10 seconds for the poll. All right, so for the next presentation, we'll be inviting Vincent Lau, co-founder and CEO from Pylon City. Vincent, are you with us?
Yes, I'm here. Can you hear me?
All right, yes, we
All
can
right.
hear you loud and clear. So the stage is yours.
Thank you. Hi, I'm Vincent, co-founder and CTO of Pylon City. Pylon City is an Internet of Energy startup, so we aspire to make cities greener, smarter, and more energy efficient through the use of IoT in the energy space. So our flagship product is actually a platform, which is Pylon for short, Pylon Decentralized Energy Network. What it does is it enables property owners to track, automate, and account for the energy sustainability goal. And the objective here is to allow them to be able to sell clean energy to their tenants and operate carbon neutral charging stations. The company was kind of founded after we went through a hackathon back in 2016, and we won the category prize for the Net Zero Carbon District. But we operationally only began around 2018 after that. We are actually one of the 7 startups from the Shell Startup Engine Cohort 3 as well. And in summary, what our platforms and solutions cover is the Pylon platform allows for our tenants as well as facility managers to be able to manage all the different energy related inputs in terms of generation and consumption within their building infrastructure. Our PowerMon product, which sits on the Pylon platform, is actually our end-to-end energy tracking solution, which includes solar monitoring as well as tracking of energy consumption. And ChargeMon is our electric vehicle charging network solution that works with PowerMon and is also on top of our platform, Pylon. So together, our solutions and platform gives rise to 2 products, which we roll out. So one is called the Pylon Charge Porch, and the other is called the Pylon Nexus, which is targeted towards residential buildings structure. So for the Pylon Nexus, it covers the use case of utility management. So households basically have a mobile app, which we call the Pylon mobile app, which allows for them to actually interface with existing smart home devices. So they could use the existing smart home device, like for example, the more popular ones like Tuya. And using that together with metering devices, we can actually allow them to take note of what are all the different things that they can actually be using within their household, what is the energy consumption like, and if they have a solar installation, that will allow them to also see the amount of energy they're generating and differentiate how much energy is actually being used from the grid versus from their solar installation. Ultimately, what happens is this gives them a very detailed energy profile, and this allows us to actually gamify the way in which their energy profile works. And that's actually the crux of the whole system. So you can imagine that household members, as they use the app and monitor the energy being consumed, they can then set carbon reduction goals, right, within the mobile app itself. And from there, if they have an existing solar installation, they could then actually purchase additional solar energy as well, which is actually stored in an ESS provided by OEM retailer, for example. So that will allow them to actually use that as a way to offset their energy profile. And some of these goals could also include tasks like switching off the aircon at certain timing and ensuring that they do not overconsume. For a Pylon Charge Port, basically we are rolling out a bunch of carbon neutral charging stations. So these charging stations uses a mixture of both solar energy as well as grid-based energy. And we are putting these charge ports such that they were able to allow EV owners using, the Pylon app to be able to start charging. And using the same credit system, they will then be able to actually purchase a mixture of solar energy with grid energy. Of course, if the amount of solar energy is available in our battery allows for it, they will be able to actually use that entirely at 100%. So this is how actually the property owner and the charge port operator works. And what we are going to do is we are actually rolling out a test bed, which was actually announced in the EMA press release earlier on this week. And this will basically cover the ability to charge both EVs as well as even unmanned delivery vehicles, which is the next things that we are working on right now. So overall, our roadmap is to combine eventually the two projects. So while one hand, we're working on gamified energy profile, we're also rolling out sustainable EV and UDV charging infrastructure that can charge both EVs and UDVs. Ultimately, in next year, we will intend to roll this out with our commercial offices, residences, and retail mall. And from there, we will be able to work with the end users, which are the tenants and merchants as well. Thank you.
All right, thank you, Vincent, for our presentation. So we'll put out a poll if any of the audience are interested to get connected with Vincent to find out more on the Pylon City solutions, to indicate your preference in the poll. So we'll open this up for about 10 to 15 seconds. Audience, feel free to post in your question in the chat function if you have any questions for any of the startup. All right, thank you again, Vincent, for our presentation. So right up next, we'll be inviting Dr. Khoo Yong-shen, co-founder and COO from QE Lab. Dr. Khoo, are you with us?
Yes, hello, can you hear me?
Yes, we can hear you. So the stage is yours.
Okay. Hello, hi, I'm Yong-shen from Quantified Energy Labs. Thank you, Ecolabs and EMA for the opportunity to share our holistic area solutions for PV asset management. Quantified Energy Labs is a deep tech spin-off from National University of Singapore. The fellow co-founders have many years of experience in solar research and industry. We aim to be the guardians of solar systems to provide exceptional visions and extraordinary insights to the PV asset. This is a picture of me doing an inspection in the Tengah reservoir. So renewable energy are widely adopted worldwide for a sustainable development. Singapore itself has an aggressive target for solar adoptions of 1.5 gigawatt by 2025. To reach that goal, additional 1 gigawatt of solar must be installed, or as much as 2 times the speed that we are installing in 2030. So PV installation must be accelerated, but how? There are challenges associated with PV installation in Singapore. As a city-state, we have a limited land space, so there needs to be efficient use of the land. We have a tropical climate. Our studies shown that PV systems degradation in Singapore is higher. Singapore, we have a subsidy-free electricity market, so cost is always a big consideration. At QE Labs, we develop and commercialize technologies that could solve the challenges above. We provide end-to-end aerial digital PV solutions for PV asset management using drone with various payloads throughout the life cycles of PV systems. The data are integrated in an online digital platform where various stakeholders can have a clear view of the status of the PV system. Our product one is a drone 3D PV system design. As you know, a proper PV system design ensures lifelong operation of a system. We use a drone to create a detailed 3D model, and using a detailed physics-based simulations, we're able to provide a very accurate PV system design. And in addition, using a parametric modeling techniques and automated workflow, we can create a PV system design over a very large area. Product number 2 is a use of drone for construction monitoring. We routinely monitor the construction's progress of solar PV systems to be used as a logistic and resource planning. The platform is also equipped with automated verifications of the as-built versus as design of the PV system. Project number 3 is we provide a comprehensive inspection of using visible, thermal, and electroluminescence imaging. So with combinations of such imaging technologies, we are able to quickly and clearly identify where are the problematic panels in the PV system. One of the projects that we are working on is the floating PV, 60 megawatt floating PV project in Tengan Reservoir in partnership with Semcop. So this floating plant was just officiated last week by PM Lee. I'm proud that we are able to contribute a part to ensure that the systems is operational and 100% healthy. The project number 2 that we're working on is the Solar Nova. So project 1 is a 60 megawatt in a single site. This Solar Nova is 60 megawatt distributed over thousands of buildings. So as you can imagine, it is very difficult to design PV systems for such distributed area. So using our automated PV system design, we're able to tremendously reduce the time required for the design and reduce the cost of the general PV system installation. Our solution is not only applicable for Singapore, it's applicable for mega cities worldwide. We estimated that 300 gigawatts of solar needs to be deployed in urban city worldwide to meet the energy demand. So this number will only double by 2050 with the double in world population. That's all. Thank you for your time, and I would like to especially thank EMA for the support work.
All right, thank you, Dr. Khoo, for your presentation. So we'll put out a poll for audience who are interested to get in touch with Dr. Khoo on QE Labs to indicate your preference in the poll. So we'll open this for about 10 seconds. And at the meantime, if any of you have any questions for any of the presenting startup, feel free to key in your questions in the chat box. All right, so right up next, we will have Dr. Stanley Wong, co-founders and CEO of Itavote. Dr. Stanley, are you ready?
Ready.
All right, then the stage is yours.
Thank you. Good afternoon, everyone. I'm Stanley from Itavote, and today the presentation topic is enabling sustainable solar energy business through advanced regeneration technology. So for Itavote, we focus on 2 technology pillars. One is advanced regeneration. The other one is called advanced solar panel recycling. Okay. Right, so this is the co-founder, I'm the co-founder, and also together there's Dr. Andy. We've been into the solar business for the past 15 years. And why regeneration is important, because when we refer to the left-hand side, you see standard P-type silicon panels normally face degradation. And normally the rule of thumb is the first year, 5% degradation, after that 1% for each year. So think about a solar lifespan of 25 years, degradation will reach 20 to 25%. And on the right-hand side, you see a solar panel installation capacity, and also there's an early load scenario versus the regular load scenario. And we see that the early load scenario outweighs the regular load scenario. And this is due to degradation and performance. And then this lead to early decommission. So how do we solve this problem? For the globally, we are leaving $7.2 billion on the table due to this degradation mechanism. All right, so what we do is that we are using this hydrogen state manipulation control. If we don't do anything, the hydrogen in the P-type panel is H+, which the mobility is the slowest. And through our advanced hydrogen manipulation control, we are able to obtain a mixture of hydrogen minus and also hydrogen plus, where hydrogen minus, the mobility is about 10,000 times faster than H+, and hydrogen neutral state, the mobility is about 100 times faster than H-. So this is able to create a mixture of hydrogen states to provide protection within the silicon solar cells. All right, so on the module level is what we do, because there are already technology out there solving solar cell level degradation, but we come in and the aim is to solve the solar module degradation. And then on the right-hand side, you see that we are confident to provide more than 5% of the power recovery through this technology. Yeah. So this is our competitive advantages compared to other solutions out there. They focus on mainly on solar cell level, but we are on the solar module level. And then our solution is also portable. So portability is a key to the market, because we are able to aim for solar farms and also, for example, solar rooftop setups. Okay, so this is a case study by using on the left-hand side, you see a panel lasts for 20-25 years. And if we go in year 5 to do regeneration, the green area versus the blue area is the potential delta that's also linked to the energy generation from this particular solar farm. Yeah. And for this technology, we are not only aiming for the solar farm market or the already installed market. This technology is able to apply for new solar panels as degradation prevention. Yeah. So the rate of the degradation, as I mentioned, it could be from 10-15% for state-of-the-art solar panels produced. But with this technology, is able to minimize the degradation down to less than 2%. Yeah, throughout the lifetime. And this is the company roadmap. And then at the moment, we are doing fundraising for a commercial prototype, which we aim to have a prototype by next year. And the last slide is showing that the technology is aligning with the government's sustainable development goals. And thank you.
All right, thank you, Dr. Stanley Wang. This is the presentation by Dr. Stanley from Itavote. If you'd like to get in touch with Dr. Stanley, do indicate in the poll, and we will connect you with Itavote after the event. So we'll keep this poll up for the 10 seconds or so. All right. All right, so right next, we will invite Ms. Tulika Rush, co-founder and CEO of SunGreen H2. Tulika, are you ready?
Hi, yes, thank you.
All right, then the stage is yours.
Hi, my name is Tulika, and I'm pleased to be presenting SunGreen H2 to you today, where we are building the world's highest efficiency electrolyzer. The way we do this is using advanced nanostructured materials. Now, hydrogen is a little bit of a magic molecule of the moment. Everywhere you go, it's very much in the news. And what's the reason why? It's because we're using hydrogen. It's seen as a net zero enabler, where you can use it to decarbonize a whole bunch of different sectors, and also to store large amounts of renewable energy, which is intermittent. But hydrogen is not really solving anyone's decarbonization problem, as long as it continues to be produced using fossil fuels, which are the current incumbent method of production. This way of producing hydrogen creates 10 times as much carbon dioxide emissions as it does hydrogen. On the other hand, we have a method of creating a zero carbon renewable fuel in the form of green hydrogen by using water electrolysis. Simply run renewable electricity and water through a machine called an electrolyzer, and this then splits water, H2O, into hydrogen and oxygen. So problem solved, right? We have a way of producing green hydrogen without producing any carbon dioxide emissions. So problem solved? Not quite. Current electrolyzers are expensive and inefficient, and the technology has certain innovation needs that have to be addressed before electrolyzers can scale up to meet the massive global demand for green hydrogen. If we take a look at the incumbent electrolyzer technologies, we have alkaline and PEM, you'll see that neither is able to solve the innovation needs at the same time. So in other words, one is low cost but low efficiency, and the other one is high cost and high efficiency. And this is a problem because if we're relying on platinum group materials like platinum, gold, iridium, titanium for high performance, then that really isn't a scalable solution to get high efficiency electrolyzer for the industry to scale up. Then we have emerging technologies like AEM, which are seeking to address the limitation of both the incumbents. This is where SunGreen H2 comes in. We have a platform technology for providing low-cost, advanced nanostructure materials applicable to all electrolyzer types. So if we take an example of a PEM electrolyzer cell, let's look at the cell level, what is happening for the water splitting reaction itself. As you can see that in the cell, we have anode and cathode electrodes, which are reliant on iridium and platinum catalysts. SunGreen H2 replaces these expensive noble materials with our proprietary low-cost earth-abundant materials. And similarly, we are replacing the materials used for bipolar plates and porous transport layers at the electrolyzer cell level with our proprietary anti-corrosion and conductive coatings. So if we think about the impact that we can make, then by reducing the amount of platinum group metals like platinum, gold, iridium, titanium, by an order of magnitude, we're able to impact and reduce the cost, the capex cost of electrolyzers by a third. We have achieved world-leading efficiency with our materials at the same time, which means that we're able to pull that lever to impact the lower OPEX cost as well. As a result, if we compare our electrolyzer offerings with the incumbent technologies, regardless of whether they're PEM or alkaline or even AEM, you can see that the performance of SunGreen H2 materials is world-class. Using these materials, we're able to supply high-performance electrodes for alkaline PEM AEM electrolyzers, as well as cells and stacks. We are also developing a modular 1 kg per day electrolyzer system that is scalable and able to meet up to 1 to 10 to 100,000 kg per day of hydrogen needs in a very scalable manner. And further up in the R&D pipeline, we also developed, using the same material science, a very innovative, high-efficiency, low-cost solar to hydrogen panel. So if we think about use cases for the tech, and we're working with and are very interested in having audience members in the panel today reach out to us for a demonstration of our electrolyzer. All we need is to be placed next to a source of renewable electricity and water to produce this green hydrogen. And it's up to our customers then to use those green hydrogen molecules for their refueling and feedstock needs, or to run them through a fuel cell and use the green electrons. We won't be building larger and larger electrolyzers. We'll just be building more and more of these same electrolyzers. The 1 kg per day system will then scale up to provide the 10 to 100 tons per day kind of a system. A little bit about SunGreen H2's journey. We were formed out of EF last year and have worked very hard to deliver our prototype, which is now up and running. Again, an invitation to everyone who's interested to attending a demonstration of our electrolyzer cell for a plug-and-play experience of producing green hydrogen. And early within the next 6 months, we expect to produce the 1 kg per day electrolyzer system for demos and pilots as well. We are a team of 8 co-founders. I'm Tulika, and I'm joined by my very capable and talented co-founder, Saeed, who is the nanotechnology guru, who is bringing his invention and has patented it. Together, we are looking to solve the decarbonization problem with hydrogen production at low cost, and we invite anyone interested to seek us out to experience green hydrogen production at low cost using our proprietary materials and patented technology. Thank you.
All right, thank you, Tulika, for your presentations. We'll put out a poll for those who are interested to get connected with Tulika for SunGreen H2. Feel free to indicate in the poll. We'll keep this poll on for about 10 seconds. If you have any questions, feel free to indicate in the chat session function so that we can address your questions shortly. All right, so right next, we will invite Andre Lawrence, co-founder and CEO from DBgas. Andre, are you ready?
Yep.
All right, so the stage is yours.
Thank you very much. Hi, everybody. So I'm going to present DBgas. I'm CEO and co-founder. So the slide isn't turning. Okay, cool. So to give you a little bit of context first, oh my God, the slides are going a little bit delayed right now. Okay. Yeah, to give you a little bit of context, hydrogen, there's a hydrogen economy that exists out there that's already much bigger than people expect. It's not clean, it's not renewable, it's overwhelmingly used in the gasoline, fertilizer, and petrochemical space. 110 billion of it is made every year. And it always needs to, when it's made, it always needs to be purified, or after it's used, it needs to be re-purified to be used more efficiently. So there's two ways to purify this hydrogen: with a chemical process and with a membrane. The chemical process is using chemicals. The membranes is using physical, just pressure, basically think like an AC filter, you push it through and it works. And these have advantages or disadvantages. I'm not gonna go through all of them right now due to the time. But basically these cause problems along the value chain. Both of these technologies have significant shortcomings that makes it very hard to capture the CO2 that's generated when this hydrogen is created in the existing infrastructure. It makes biomass gasification, the hydrogen generation made by waste in municipal dumps and etc. be very difficult. And it makes a large amount of the hydrogen made in a refinery to be used inefficiently, and causes millions of dollars per refinery of losses every year. And many of the green hydrogen that we talk about today have a problem at the separation level because of the shortcomings of both of those technologies. So we have created a new next generation gas separation membrane. It's just a fiber, as you see here. And very simply, the gases, there's mixed gases. We don't make hydrogen. We get, for example, 50% CO2, 50% hydrogen. It floats around this tube, and only the hydrogen makes it out to the center, and you get pure hydrogen. What we've done is we've made that polymer fiber be significantly more robust. So it's resistant to acidic gases, resistant to higher heat, at different pressure profile, and it's all done at a very intentionally commercial scale to be deployed. Now, solves problems across the value chain, not in every single use case in the world, but it solves an immense amount of problems for the next generation of hydrogen products and use cases. Now, we already have an existing market that's billions of dollars in the recycling and the optimization of existing hydrogen infrastructure. But in the carbon capture space or in the green hydrogen generation space, we're talking about tens of billions of dollars in each of those individual use cases. And on top of that, according to the International Energy Agency, we think that the overwhelming infrastructure will switch to carbon capture, which will be probably our biggest, carbon capture hydrogen, which is probably going to be our biggest infrastructure play. Now, we are, the climate of impact of this is massive. Hydrogen is going to be a major item, but capturing the CO2 that comes out of the hydrogen plant will represent 2 gigatons of CO2 by 2050. Now, we are unique in the sense that we are both practical and have a next generation performance. And there's really nobody else in our space like this. There's a lot of newer technologies coming out of research lab, et cetera, but that have very big difficulties in manufacturability. And there's the existing infrastructure that's much more lower performance, but practical. So we have an exploding pipeline of clients already. We have over 8 clients in multiple industries and in multiple use cases. And we sell this product as a quick sort of equipment sale with a resupplying cartridge on the back. We have all the IP. So Ali, my co-founder, has developed this technology independently. He was at NUS and worked with NUS and BASF in the past, but he developed this technology completely independently, and we're currently in the process of patenting it. And I know I'm zooming through this crazy fast, but it's due to time. So we actually have closed a round for $2.6 million US, or about $3.5 million Sing, and we have 500K left, but that's rolling afterwards to build our first commercial manufacturable facility that'll be shelling out about $3 million worth of product every year. My name is Audrey Lorenzo. I'm a repeat entrepreneur and the co-founder of this. I've raised the company at Series B $15 million before, and that's my key, right? All right, thanks a lot.
Thank you, Andre, for our presentation. So we'll put out a poll for audience who are interested to get in touch with Andre from DBgas, and you can indicate on the poll so that we can connect you with Andre post-event. So we keep this up for about 10 seconds. So I believe we have had a fast-paced and enjoyable session with 8 inspiring and transformative startups in the energy innovation space. And if you'd like to stay updated on the latest news happening and check out more promising startups in Singapore, do check out the Ecolabs linking page where you can find the link to in the chat box. So before we move forward with the agenda, I would like to invite all presenters to turn on your video. All right. So we have all presenters. Okay, we have another few more. So now we are going into the Q&A sessions. With interest of time, I'm going to just ask one short question, and I hope all of you can give me a one-line answer to it. But let's just wait for a while. I think Abhishek is not in yet. Maybe he's facing some technical issue. How about this? I'm going to ask a question. Let's circle this in reverse order of the presentation. Okay, so the question is, give me a one-line answer on how you imagine the future of energy will be. So in reverse order, can I have Andre first?
No choice. Full renewable with hydrogen as a management vehicle for a lot of this renewable energy.
Awesome. Tulika?
The future of energy is going to be decarbonized, decentralized, and democratized. And hydrogen is going to play a great role in that, green hydrogen.
Awesome. I see what you're doing. Stanley, one-line answer how energy will be?
Yeah, so I think the future of energy will be linked to the extracted materials from old materials. So reused energy.
All right, circular economy, very nice answer. Yeah. Dr. Koo, a one-line answer?
The future of energy will be fully digitized and consist mostly of renewable energy.
Awesome. Vincent?
The future of energy is, as what I suggested, to be the Internet of Energy. We'll be treating it as though how we are treating the Internet right now.
Amir?
The future of energy will be green, smart, and distributed.
Awesome. Joshua?
We believe in a cooperative energy platform system, where all the different stakeholders will own a part of it. So this is a truly democratized energy platform in due time. Thank you.
All right. The last but not least, Dr. Abhishek, what would be the future of energy?
Energy will be green and distributed, and hopefully controlled in cloud. I mean, it's Internet of Energy is the future.
All right, very good, very good. It's all good answer that I'm having, and thank you so much for your time to be with us in today's sessions. And as we have come to the end of the Startup Showcase sessions, I really appreciate your support in this presentation. I believe we will take a very quick photos while you are talking about this. And thank you so much again, and back to Shifting.